Namaste students. In the last class we are solving problems on solution of system of equations by matrix method. So we have used inverse of a matrix to find the value of the variables x, y and z, for which we have used the formula x is equal to A inverse into B. I have already told you that one problem will be definitely asked for 5 marks in the examination. I have asked you to solve problems in the worked example. Anyhow, I will be solving the remaining 3 problems in the worked examples. So if you have understood the method, let us move on with the problems. So let us take the worked examples. 2x plus 5y is equal to 1. 3x plus 2y is equal to 7. This is what we do. First, form the matrix A. 2, 5, 3, 2. What is the matrix of variables? It is x, y. What is the matrix of constants? It's 1, 7. Now, solution is given by x is equal to A inverse into B. What is A inverse? 1 by determinant A into adjoint A. So, find out determinant A first. It is 2, 5, 3, 2. It is 4 minus 15. We will be getting minus 11. So, which is not equal to 0. Hence, we conclude that inverse exists. Further, to find out adjoint A11, it is 2. A12, that is cofactor of 5, minus 3. A21, cofactor of 3, it's minus 5. A22, the cofactor of 2, which is equal to 2. So what is the cofactor matrix? Cofactor matrix of A is 2, minus 3 and minus 5, 2. What is the adjoint of the matrix A? It is the transpose of the matrix of cofactors. 2 minus 5 minus 3, 2. As I have already told you, it can be also got directly by interchanging the diagonal elements, by changing the signs of the other elements. So, 1 by determinant A into adjoint A, 2 minus 5 minus 3, 2. Solution, x is equal to A inverse into B. What is x? 1 divided by minus 11, 2 minus 5 minus 3, 2 into B. What is B? It is 1, 7. Minus 1 by 11 into 2 minus 35 is. Further, minus 3 plus 14. So you will be getting minus 1 by 11 into 2 minus 35 minus 33 minus 3 plus 14, it is 11. So this is the matrix X, matrix of variables x, y, multiply minus 1 by 11 into minus 33, it is 3, minus 1 by 11 into 11, it's minus 1. Equate, by equating you get x is equal to 3 and y is equal to minus 1. So value of x and y exists, hence we conclude that the system of equations is consistent. Suppose if you substitute x is equal to 3, 2 3s are 6 and y is minus 1. 5 into minus 1, minus 5. 6 minus 5, we get 1. Hence the problem is verified. The values x and y which we have got, hence the system of equations are said to be consistent. I think you have understood this. Now, I take up the next one. 3x minus 2y plus 3z is equal to 8. 2x plus y minus z is equal to 1. 4x minus 3y plus 2z is equal to 4. This is what the system of equations is. You need to find, this is the matrix of coefficients, matrix of variables and matrix of constants. So what is the solution given by x is equal to A inverse into B? So to find A inverse, we need to find determinant A first. This 3 minus 2, 3, 2, 1 minus 1, 4 minus 3 and 2. So 3 into 2 minus 3 minus half minus plus 2 into 4 plus 4 plus 3 into, it is minus 6 minus 2. We get 3 into minus 1 plus 2 into 8 plus 3 into minus 1. Minus 3 plus 16 minus 30. So that's what we will be getting. So what is the answer you get? Minus 3 plus 16 is 13. 13 minus 30 is minus 17, not equal to 0. Hence, A is non-singular and inverse exists. Before finding inverse, you need to find out the matrix of cofactors. That is, until you can find out that job. What is A11? A11 is positive. The cofactor of 3, leave that round column, 2 minus 3, which is equal to minus 1. I take up A12, the sign is negative. So cofactor of minus 2, leave that round column, 4 plus 4, it is 8. So you will be getting minus 8. I take up A13, sign is positive. I want cofactor of 3. What is cofactor of 3? Leave that round column, minus 6 minus 4, which is equal to minus 10. I take up A21, the sign is minus, cofactor of 2, leave that round column, minus 4 plus 9, minus 4 plus 9 will be, it is 5, minus 5 is. I take up A22, the sign is positive, cofactor of 1, leave that round column, 6 minus 12, which is minus 6. A23, the sign is negative. So we want cofactor of minus 1, leave that round column, minus 9 plus 8, minus 9 plus 8, it is minus 1, minus of minus 1 will be plus 1. Further, I take up A31, sign is positive, 4, cofactor of 4, you want leave that round column, minus 2 into minus 1, 2 minus 3, which is equal to minus 1. I find out A32, cofactor of minus 3, you leave the round column, minus 3 minus 6, it is minus 9, so we will be getting plus 9. A33, so cofactor of 2, leave the round column, 3 plus 4, you will be getting 7. Cofactor matrix of A, minus 1, minus 8, minus 10, minus 5, minus 6, 1, minus 1, 9, 7. What is the adjoint of the matrix A? It is got by taking the transpose of the matrix of cofactors, minus 1, minus 5, minus 1, minus 8, minus 6, it is plus 9, then minus 10, 1, 7. This is what adjoint is. What is A inverse now? 1 by determinant A minus 1 by 17 into minus 1, minus 5, minus 1, minus 8, minus 6, 9, minus 10, 1, 7. This is what A inverse is. You want finally X, A inverse into B. What is A inverse? Minus 1 by 17 into minus 1, minus 5, minus 1, minus 8, minus 6, 9, minus 10, 1, 7 into B. What is B there? B is the matrix of constants, 8, 1, 4. Now you multiply, matrix multiplication, it's minus 8, minus 5, minus 4. Next, it's minus 64, minus 6, plus 36. Next, minus 80, plus 1, plus 28. Now, minus 1 by 17 into minus 8, minus 5, minus 13, minus 4, minus 17, minus 64, minus 6 is minus 17, minus 17 plus 36. So, minus 17 plus 36 will be minus 34. So, minus 80 plus 1 plus 28. Minus 80 minus 29, it's minus 59. So, this is the matrix S. This is nothing but x, y, z. Multiply minus 1 by 17 into minus 17 1, minus 1 by 17 into minus 34 it is 2, minus 1 by 17 into minus 51 it is equal to 2. So by equating you will be getting x is equal to 1, y is equal to 2 and z is equal to 3. So you will be getting the values 1, 2 and 3. Substitute in the given equation, it will be verified. Further we conclude that the system of equations are consistent. Think you have understood how to solve this problem. Please understand properly. These are very, very important problems for examination. First find out determinant K, ensure that it is non-singular and inverse exists. Then you find out the cofactor matrix. After finding cofactor matrix, you have to find out adjoint K, which is the transpose of the matrix of cofactors. Then A inverse will be 1 by determinant K into adjoint K. Solution is given by x is equal to A inverse into T. So by multiplying and equating, you will be getting value of x as 1, y as 2 and z as 3. Let us take next problem, which is a statement problem. Statement problem it is. So you read the problem carefully. Sum of the three non-zero integers is 6. Let us consider the integers as x, y and z. According to the first statement, sum of the three non-zero integers is 6. Means we have to take x plus y plus z as 6. That is equation 1. Next. So if the third number is multiplied by 3 and added to the second, the answer is 11. Third is z now. When you multiply 3 to it, it becomes 3z. And added to the second means y, that becomes 11. That's what I mean. Next. Sum of the first and third is twice the second. Sum of the first and third is x plus z is equal to twice the second means 2y. This is what the equation is. First I have already told you, verify whether the variables x, y, z are in order and constants are written in the RHS. Now how this can be written as x plus y plus z is equal to 6. Second one, 0x plus y plus 3z is equal to 11. Third one, x minus 2y plus z is equal to 0. This is what we have. So now let us form the matrix A. It is 1, 1, 1, 0, 1, 3. Third is 1 minus 2, 1. What is the matrix of variables x? It is x, y and z. Matrix of constants, it is 6, 11, 0. This is what we get. So solution is given by x is equal to A inverse into B. You need to find out A inverse. To that end, you need to find out determinant A. Ensure that it is non-singular. 1, 1, 1, 0, 1, 3, 1 minus 2, 1. Expand it. 1 into 1 plus 6 minus 1 into 0 minus 3 plus 1 into 0 minus 1. 7 plus 3 minus 1. So what happens now? We get 9. Determinant A is equal to 9, not equal to 0. So hence we conclude that inverse exists as it is non-singular. Now we find out the adjoint here. A11, A11. So you want A11, cofactor of 1, leave the lone column, 1 plus 6, that's equal to 7. A12, it's minus, leave the lone column, 0 minus 3, it is minus of minus, you get plus 3. Further, A13 I take, so sign is positive, 1, leave the lone column, 0 minus 1, it's minus 1. A21 minus. So you want cofactor of 0, leave the lone column. 1 plus 2, it is 3. Minus 3 you get. A22 you take, sign is positive. For 1 you want, leave the lone column. 1 minus 1, which is equal to 0. A23 you take, sign is minus. for this element, leave the row and column, minus 2, minus 1, minus 3, we will be getting plus 3. Next, I take up A31, cofactor of 1, 3 minus 1, which is equal to 2. To find out A32, sign is minus, cofactor of minus 2, leave the row and column, 3 minus 0, which is equal to 3. And we find out A33, sign is positive, cofactor of 1, leave the row and column, 1 minus 0, which is equal to 1. So I take up cofactor of matrix A, write it in order, 7, 3, minus 1, minus 3, 0, 3, 2, minus 3, 1. What is the adjoint of the matrix A now? Adjoint 7, minus 3, 2, 3, 0, minus 3, minus 1, 3, 1. So this is what adjoint is. 7 minus 3, 2, 3, 0, minus 3 and minus 1, 3, 1. What is A inverse? 1 by determinant A. What is determinant A you have? 9, 7 minus 3, 2, 3, 0, minus 3, minus 1, 3, 1. This is what A inverse is. Now what is the solution given by x is equal to A inverse into B? 1 by 9 into 7 minus 3, 2, 3, 0, minus 3, minus 1, 3, 1 into B. What is B? B is 6, 11, 0. Let us multiply 7 6 are 42 minus 33 plus 0. Second row 18 plus 0 plus 0. You get 3 6 are 18, 0 into 11 0, minus 3 into 0 0. Last row minus 1 into 6 minus 6 plus 11 3s are 33, 1 into 0 is 0. So now what happens now? 1 by 9 into 42 minus 33, we get 9, then 18, 33 minus 6 plus 23 is 27. This is the matrix X, it is the matrix of variables x, y, z, that's equal to 1 by 9 into 9, 1, 1 by 9 into 18, 2, 1 by 9 into 27 is 3. Equate x is equal to 1, y is equal to 2, z is equal to 3. So we have got the values of x, y, z as 1, 2 and 3 respectively. I think you have understood how to solve this problem. So understand the method. You first, when the equations are given, first consider, write them in order, x, y, z in order. Then you can find out determinant A, ensure that it is non-singular. Then you can find out adjoint of the matrix. A inverse is 1 by determinant A into adjoint A. Then take the solution using x is equal to A inverse into B. You will be getting value of x, y and z. I think you have understood how to solve these type of problems. If you have understood all these worked example, we can start with miscellaneous problems. Students, we start with miscellaneous problems. So far we have discussed with all the problems in the exercises and also in the worked examples. Based on these concepts, we are going to solve miscellaneous problems. Today, I will be solving as many number of problems as possible. So I take up the first one. So see here, you have to prove that the determinant is independent of theta. So let us consider miscellaneous exercises. First problem, which is the determinant x sin theta cos theta minus sin theta minus x 1 cos theta 1x. I have to show that this is independent of theta. So it is independent of theta. How to solve this? Let us write x into minus x squared minus 1 it is. Minus sin theta, you expand this, minus sin theta into, it is minus x sin theta minus cos theta. plus cos theta into expanded cos theta into minus sin theta plus x cos theta. Now multiply minus x cube minus x plus x sin square theta plus sin theta cos theta minus sin theta cos theta plus x into cos square theta. I think you have understood how we got this. So what happens? Plus sin theta cos theta minus sin theta cos theta cancels. Now it is minus x cube minus x plus x into, from these two you can take x as common factor, x into you will be getting sin square theta plus cos square theta. Minus x cube minus x plus x into 1 it is. You know sin square theta plus cos square theta is 1. So you will be getting minus x cube minus x plus x cancels. So you will be getting minus x cube. So value of the determinant is minus x cube. So it is, I conclude, it is independent of theta. Minus x cube doesn't have theta, hence we say that it is independent of theta. That's what we have been asked to do. So very simple problem, given a problem, expand it, use the formula sin square theta plus cos square theta as 1. Then you will be getting minus x cube, which is independent of theta. Now, it is given, prove that A square BC, B square CA, C square AB is equal to 1 A square A cube, 1 B square B cube, 1 C square C cube. You have to prove it without expansion. We have to prove this without expansion. We are not supposed to expand the determinant and expand RHS, expand LHS separately and equate them. We are not supposed to do it. What we have to do? I take LHS ABC, A square, B square, C square, BC, CA, AB. What I can do now? See, you have to get this answer. 1 A square A cube, 1 B square B cube, 1 C square C cube. You should have 1, 1, 1 in one first column. See, to that end, I take one simple operation, multiply and divide by A, first row by A. You will be getting A cube by A. It can be written as ABC by A. What I have done? I have multiplied and divided first row elements by A. Similarly, for second row elements, multiply and divide by B. You will be getting B square by B, B cube by B, ABC by B. Similarly, for the third row, multiply and divide it by C, C cube by C, ABC by C. I think you have understood this step. What I have done? R1 dash, that is first row, multiply and divide by A. Second row, multiply and divide by B. Third row, multiply and divide by C. See here, I can take 1 by A as common factor from the first row. What you will be getting? A square, A cube, ABC. I take 1 by B as common factor from the second row, B square, B cube, ABC. I can take 1 by C as common factor from the third row, I get C square, C cube, ABC. Think you have understood this? I continue it here, LHS. You have got 1 by ABC. You take ABC as common factor from the third column. What happens when you take ABC as common factor from the third column? First column remains as it is, second column remains as it is, and third column we have taken ABC as common factor, so we get 1, 1, 1. I continue, ABC gets cancelled. Now, I think you have understood how to do it. What I have done now, I have interchanged first column and third column. So we have got negative sign. Use the properties. If you interchange any two columns or any two rows, sign will be changed. Again, you interchange one more column, that is C2 and C3. A squared, B squared, C squared, A cube, B cube and C cube. What I have done here, I have interchanged second and third columns. Again 1 minus. So minus into minus it is plus 1 1 1. A square, B square, C square and A cube, B cube, C cube we get. That's what the RHS is. I think you have understood how to solve this. Very simple. First step is crucial. Multiply and divide the first row elements by A. Second, multiply and divide second row elements by B. Multiply and divide third row elements by C. Then you can take 1 by A as common factor from first row, 1 by B from second row, 1 by C from third row. Then take ABC as common factor from the third column. Then interchange two columns. If you interchange C1 and C3, you get 1 minus. Then if you interchange C2 and C3, you will be getting one more minus, minus into minus plus, and hence you get the desired answer. I think you have understood how to solve this problem. So there was the second problem is miscellaneous. I take up the third one. It is given, evaluate. It is given cos alpha into cos beta. Write down the problem. You need to evaluate cos alpha into sin beta. The second column elements I am writing now. Sin alpha into sin beta. Then third column minus sin alpha, 0 and cos alpha. You need to evaluate this. Very simple. You have to just expand it. What happens when you expand? So cos alpha into cos beta, multiply cos alpha into cos beta minus 0, minus cos alpha into sin beta, leave the round column, minus sin alpha into cos alpha minus 0, plus of minus sin alpha into, leave the round column, minus sin squared alpha and sin beta minus sin alpha into cos squared beta, minus sin alpha into cos squared beta. So what happens now? Cos squared alpha into cos squared beta, you get minus into minus plus sin squared sin alpha cos alpha, it is cos squared alpha into cos alpha into cos into sin beta, you get. Then minus into minus plus, you will be getting plus sin alpha into. Now what happens? You will be getting minus into minus plus sin cube alpha into sin beta, minus into minus plus sin squared alpha into cos squared beta. It's very simple. Now how this can be solved? So let us take here, I take sin squared alpha as common factor. What is that sin? If you take cos squared beta as common factor there, you will be getting cos squared alpha plus sin squared alpha plus here in these two terms, you need to take a common factor. Which is common factor now? Sin alpha into sin beta is common factor. If you take sin alpha into sin beta, you will be getting cos squared alpha plus sin squared alpha. I think you have understood this. So from these two, sin alpha, sin beta, here also sin alpha, sin beta. If you take sin alpha, sin beta, you will be getting cos squared alpha. Since you are taking sin alpha and sin beta common factor, we get sin squared alpha. Now cos squared beta into 1 plus sin alpha into sin beta into it is equal to 1. I think you have understood this. Please carefully expand. Cos alpha into cos beta into cos alpha cos beta minus 0 minus cos alpha into sin beta minus sin alpha cos alpha minus 0. You get minus sin alpha into the electron column minus sin squared alpha into sin beta minus sin alpha into cos squared beta. You have expanded it and you have got this much as answer. I think you have understood how to solve this. So please understand how to expand this. Cos alpha cos beta is given, cos alpha sin beta minus sin alpha minus sin alpha cos beta 0, sin alpha cos beta, sin alpha sin beta and cos alpha. This is the expansion. I think you have understood this. It is given if determinant b plus c, c plus a plus b, c plus a plus b, b plus c, a plus b, b plus c, c plus a is equal to 0. Prove that either a plus b plus c is equal to 0 or a is equal to b is equal to c. If this condition holds good, you need to prove that either a plus b plus c is 0 or a is equal to b is equal to c. So let us take here r1 dash, r1 plus r2 plus r2. What happens when you add by row wise? 2a plus 2b plus 2c, you get 2a plus 2b plus 2c. Here also 2a plus 2b plus 2c. There also 2a plus 2b plus 2c. Second row, c plus a plus b, b plus c. Third row, a plus b, b plus c, c plus c. That's equal to 0. Now, shall I take 2a plus 2b plus 2c as common factor from the first row? 1, 1, 1. Here c plus a plus b, b plus c, a plus b, b plus c, c plus a is equal to 0. Now, you can take R2 dash, C2 dash, C2 minus C1, C3 dash, C3 minus C1 or C3 minus C2, anything. So what happens now? 2 into a plus b plus c into 1 c plus a plus b. Subtract this 1 minus 1 0, a plus b minus c minus a. We will be getting b minus c, b plus c minus a minus b. We will be getting c minus a. Now c3 minus c2, 1 minus 1 0, b plus c minus a minus b. We will be getting c minus a, c plus a minus b minus c. You will be getting a minus b is equal to 0. I think you have understood this. C plus a minus b minus c. Now you can expand because two rows are there. So 2 into a plus b plus c into 1 into b minus c into a minus b minus c minus a, the whole square, is equal to 0. I think you have understood this. 1 into b minus c into a minus b, c minus a, the whole square is equal to 0. Now you can equate 2 into a plus b plus c is equal to 0. Therefore, a plus b plus c is equal to 0. The first condition we have got. We have to take b minus c into a minus b minus of c minus a is equal to 0. So, by inspection you can solve when this will be equal to 0. So, this will be b minus c into a minus b is equal to c minus a whole square. When this condition holds good. This condition holds good only if a is equal to b is equal to c. If we take a as b as c is equal to 0, we will be getting this as 0. They have asked us to prove either a plus b plus c is equal to 0 or a is equal to b is equal to c. So I think you have understood. So simple properties of determinants, and you can do this. Students, in this class we have solved around 4 problems on miscellaneous, and 3 problems on the word examples. I think you have understood all these problems. Please concentrate on these problems. We will be solving more miscellaneous problems in the next class. That's all for the day. Thank you.